I think we'll start the presentation of Lenny. Thank you.
Hi everybody. I can see that the party last night was pretty great because it was fun to get up. Today I'm going to talk to you about the components used by Drupal, the Symfony components, and I'm going to show you what they are, what they do, and how they do. A little summary about me. I'm Lenárd Palkó. I'm a development manager at Arad and Targu-Mures, and since last year I'm also a certified developer, Symfony certified developer. If you want to get contact with me, you can write me an email or on Twitter. Okay, so how many of you have not heard of Symfony until now? Okay. So there are guys that didn't hear of Symfony until now? Okay. So as you know, Drupal 8 has Symfony inside, and this means that Drupal 8 uses some components, some Symfony components. Basically, Symfony, the framework, is also based on these components, and Drupal 8 is using some of them. As I said, I'm going to talk a little about Symfony, and I'm going to go in depth in on the Symfony components that are used in Drupal. So, what is the Symfony project? The Symfony project has two parts. The components on which the Symfony framework is built on. And the main issue of the Symfony project is the community. As you can see, there are a lot of contributors, developers, and a staggering 1 million plus monthly downloads on the Symfony component. So, what is the Symfony framework? The Symfony framework is a full stack web framework. This means that you have components that resolve all the parts of a web application. You have request management, response generation, session management, and all the between parts. It works out of the box, so you can install it and you already have a functional application. As I said, it's easy to install also, because it's not just works out of the box, it's easy to install, and it's also easy to extend. It uses bundles for the file by hand, and in the composer way, it has a hook that will ask you to configure these parameters. So this is the main difference between them. Of course, there is the possibility to install them with zips, but these are the recommended ways. So, besides being a full-stack framework, as I said, Symfony is a set of reusable decoupled PHP components. So the framework uses also the same components that are made available for other applications to use, other frameworks to use. And each of these components resolve an individual problem of web development. So as I said, request management, session management, loading a YAML file, or dispatching events. So these are individually resolved by these components. So this is the standard definition of the components. And the main benefit of this is that all these problems are already resolved by these components. So by using these components, you can focus on what matters for other frameworks, in this case Drupal. So you don't have to wrap the request object, you don't have to make the workflow of converting the request into a response. You can focus on what's important for Drupal. Why is this good? Because having small parts implemented, it's easy to understand and it's easy to maintain. So the components handle specific issues. They are not tied to any framework, so you can use them in whichever framework you want. The components can evolve individually, so updating the request object doesn't impact the dispatching of events. So this can evolve individually, and of course they can be easily replaced because you don't have to rewrite all the code. So currently Symfony has 30 components, from which only a few are used in Drupal. And in the upcoming, I'm going to discuss deeper into these components. So let's start with the basics. Class loader. So you know that to use a class, you have to include the file that the class is in. So the class loader component handles this case for you. There is two ways: manually include all the files that contain the classes that you want to use, or just using the class. Okay, so well, that's great, but how does this component find the file for a class that I want to use? The answer is standards. Because if we agree on the way that we are going to name the folder structure, the file name in which the class exists, then we can build automatic tools to include these files. And the role of this group, FIG, just a curiosity, how many of you have heard of FIG? Okay, so not so many. So FIG is a PHP framework interoperability group, which has the goal to increase interoperability in the PHP ecosystem. So this means that developers that are developing in Drupal to be able to develop in other frameworks also. Because until now, what you have used in Drupal was really beneficial for Drupal. You couldn't use that in Symfony, for example. And it has interface. So the result of this is an interface that can be implemented by lower components, and this way anybody can use those components easily because they have a defined interface. And for this component, we are going to talk about PSR4. It's an improved auto-loading feature. Here they are defined the ways to put the folder names, the class names, so we can load them easily. So what happens with auto-loading is that the user code wants to use a class object. PHP sees that it doesn't have that class object, and it asks the registered autoloader to load the file. The autoloader has a setting to know where to start looking for those files, and from then, based on the namespace of the class, it's going to find the file to load. So this is how you can define a class loader. This class loader is from the PHP, the Symfony component. You define the class loader, you add a prefix to a folder, and then you register the autoloader. And this way you can make use of the class, and you don't have to include the file because it will find it in that directory structure, and it will include it automatically. Actually, Drupal 8 is not using this class loader, but it's on the same principle. It uses Composer's class loader, which functions exactly the same way. Follows the PSR4 specifications, and little bit of Composer now. Composer is a dependency manager for PHP. It uses a centralized repository for all the components. It is packages.org. And if you are a PHP developer for a while now, you probably use Peer to install some libraries. And this is mainly Peer on steroids. You can install it like this. It's really, really simple. And after that, if you have a Composer JSON file, this is actually the Composer JSON file from Drupal 8, a part of it, you can see that you are defining the required section. In the required section, you define what dependencies the project has and which version to use. And after that, you can define the namespaces. You can define where this autoloader finds the namespaces in Composer, and after that, you run Composer install, which will create a log file where Composer will write all the versions and will log the versions for which the requirements were installed. So after you commit this Composer log file, all of the developers from your team are going to use the same version of the dependencies. So this way you have a really easy management of the dependencies. You don't have to worry about one developer having other version and it's working for him and it's not working for you. So it's really easy. Okay, let's go to the next component, which is the dependency injection. And what this component does is that offers a centralized way in which you can construct your objects in your application. This is my favorite component from the Symfony components, and because it's really, really powerful. It implements a powerful design pattern, this dependency injection, and using this design pattern, your code follows the I principle from Solid. What does I mean from Solid? It stands for inversional control, which means that you are supposed to decouple your dependencies from your object. defining an interface on the storage and injecting this dependency through the constructor of our class. This way, we can use whatever storage we want without modifying our class. So basically, we use this example is going to be the same with the first one. The difference is that here we can use whatever other storage we want, and the code is easily testable because we can also mock the storage, and we don't have to use the exact implementation of the storage. And basically, this is dependency injection. So you are using dependency injection when your object receives its dependencies. It's not coupled with them. And there are three types of dependency injection: constructor injection, we saw it earlier, method injection, called setter injection, and when you set a field, it's called property injection. So, okay, but this can be resolved without a component. Why do we need this component? Because of the dependency injection container or the service container. These are equivalent. What does this do is, let's say in a controller you need the config saver service. And the container says, oops, I don't have it, but I can build it because the container has a configuration file from which it can load the dependencies. It sees that it has a storage dependency. Let me check what this dependency is about. Oh, I see it's a file storage. Let me build that too. Inject it in the config saver service, and then you can use it. So this way, you don't have to worry about this part, to inject the file storage, because this is handled by the dependency container. So you can use config saver without any hassle. Okay. So you might see that I'm talking about services here. What is a service? It's actually a plain PHP object. It's nothing special about it. That performs some tasks. As we see, this we had two services in our example. It's the config saver service that only does saving the config values, and the file storage which can save it in a file. So these are the services. As I said, the dependency injection container can inject services and also parameters based on a configuration file. That can be written in YAML, XML, or PHP, what you prefer. But you would say that this would slow your code because it has to read the YAML file to build the dependencies, and you can use it only after that. But no, because the service container can be compiled into plain PHP. This means that when you need anything from the dependency injection container, it's calling simple PHP method. And because this is done with config files, it would be a little harder to add dependencies or modify dependencies on the runtime. For these are the compiler passes, because maybe as a Drupal developer you will hit this notion. What a compiler pass is a way to modify already registered services. So in this way, the services that are registered through the config file can be modified during runtime. Where you can see this in Drupal, the dependency injection component. This is the container of Drupal. You can find it in this namespace. the main results of this are the request and the response objects. Because as you can see, in the process of the communication from the browser to the server, from the user to the server, we can clearly define the specs for a request object and a response object. So we can wrap all the things that we have in PHP into objects from this component. The request object is a simple object-oriented representation for a request message. A request message has headers and can contain content also. So it holds information about the client request and it wraps the existing global PHP parameters into bags, and this way you can access the parameters in the same manner using the same interface. So here is how you do it, plain PHP side, the way, and this is how you can do it in a request object. You create it from the globals, and you can access these values easily from the request object. And you can have also other methods that hide the complex operations, which in other case you would have to implement them yourself. So getting the client IP, for example, has checks on several headers and on trusted proxies, but you can use it just by get client IP and it will do all this behind the scenes. The response object is object-oriented representation of the response message. It holds the information to be sent to the user, containing status, code, headers, content. Again, this is how you would do it. Simple PHP way. Setting headers, status code, setting cache control, cookie, and the content. And this is how you can do it with the response object. You only create a new response, set the status code, you can set the cache control. You don't have to know how exactly this is named, because this function handles it. You can set the content and you can manipulate the cookies. A big gain here is that, for example, you don't have to set the content, the last operation of the chain. You can set the content whenever you want, and after that you can modify other things from the object. Some other services that are found in HTTP Foundation, request tag as a stack for the requests coming on the same request, sub-request mainly. It has an implementation for the session. It has an implementation for upload file, a section for uploaded file. So makes things easier. Next component, the event dispatcher, which puts at our disposition a bus through which other components can communicate in our application. It implements the mediator pattern. So you can see that none of these entities are communicating between each other. They are communicating with a central entity, and they don't have to know that other same entities exist. What we gain from this is a decoupled system. We have an event-based communication with a central entity, so we don't have to have the listeners communicating between each other. So the listeners are independent, and removing a listener doesn't affect the system. are two types of listeners, of consumers. Listeners and subscribers. The only difference between these two is that listeners don't know which event do they subscribe for. So you tell this listener is subscribed for one particular event, and for the subscribers, when you register them in the event dispatcher, they already know for which event they are going to be triggered. So this is the only difference between them. Here you can see extract from Drupal, and you have an implementation of subscriber. The event subscriber only has to implement event subscriber interface, and it knows in this function get subscribe events on which events it's going to listen and what functions it has to call when the event happens. Okay, so this is for event dispatcher. This is some way the same as the hook system from Symfony, but resolved in object-oriented way. The next one, the routing. So the routing component maps the HTTP request URI to a controller that can handle it. And it does it based on configuration. So how this happens is when a request comes into the kernel, it dispatches the kernel request event, for which the routing component has a listener, and it loads the configuration, or it searches through its configuration to see if for this particular request it has a setting, and if it matches it, it sets the controller parameter on the request object. And from this on, the kernel handles the rest. So here again you can see a decoupling of the what things have to do, because routing only does finding the controller for the request. It doesn't do anything else. Only things that are related to this thing. So it listens to the kernel request, matches the config, and sets the controller on the request. Actually, Drupal is using a dynamic router, which is also implementing the same interfaces as the request from the Symfony component, but it has enhancers. This dynamic router was implemented in the Symfony CMF. It's used by the Symfony CMF routing. And what it adds in plus for the Symfony component are the enhancers, from which you can type in some of your controller's dependencies, and will not only pass the variables from the request, but it will also try to resolve these dependencies. So if you, let's say, have a node ID passed to the controller, and to type in it that this will be a node object, what will be sent to the controller is actually a node entity. kernel interface, which is implemented in Drupal, has only one method, the handle method. And this is how it looks, handling of the request coming from the user. You have a request object that you can construct from the globals. You call handle on the kernel, and you got a response which you can send back to the user. And that's it. Some events that are in the HTTP kernel. The request event comes when the request enters in the stack. When the controller is resolved, you get a controller. When the controller returns a response, you get the response event. In case that the controller doesn't return the response object, you get the view. So this event, you can have listeners listening on this event and transform the result of the controller into a response. Finish request, where you can have listeners doing other stuff not related to the response. And if it implements the terminable interface, you can also terminate you can listen also on the kernel terminate event, which is dispatched after the response was sent to the user. And there is also the kernel exception event. In the case of exception, you can have listeners handling this exception. So this is the workflow of what I explained earlier. In the HTTP kernel, it enters a request, it dispatches the request event. There can be request listeners that if they return a response object, all this path is skipped. So you don't have to resolve the controller if one listener from the request event returns a response object. If it doesn't return a response object, then the kernel resolves the controller, and as I said, the request listener listens from the routing component, listens on this event. It sets on the request the controller, and what this does, the kernel, is that it finds the controller and it instantiates it. After this is done, it dispatches the controller event. Here you can modify the controller in your application if you want to. Then it calls the controller, and if the controller returns a response object, it goes further. If it doesn't return a response object, but it returns something else, it dispatches the view event, where view listeners can transform it into a response object, and the workflow resumes from here. After this, it dispatches the response. After it has a response, it dispatches the response. After here, you can modify the response in your application if you want to. Then it dispatches the finish request event and returns the response to the user. And here you can have the terminate event in case you want to do operations after the request was sent. For example, you want to send the emails and you don't want the user to wait until the email is sent. You just send the request, and after that you can do the sending. And if there is an exception, the kernel handles the exception and then resumes the path from here. Okay. Next, we have the validator component. This offers generic class validation. So you can have validation on any PHP object. It is also configuration based. You can have translatable error messages. So this is how validation looks. You can define the validation like this on an object, a plain PHP object. You have one property on which you set a constraint. This is a constraint, and you only call the validator component and validate the object, and that's it. And this will return a list of that thing, you can build your own framework based on these components. And here's all these lines that you see here is actually a full stack framework. You have a root collection, so you don't define them in a configuration file. You actually give the routing here. You have a path, which is distance 2, and closure as a controller object. So this, let's say the control is already resolved for this case. Then you build a request. You match the root in your roots for this request. Then you subscribe to this event of getting the request. This is the router listener. It resolves the controller, which means that it's going to call this function. And then you can have the kernel, which handles the request, and then it sends it. And that's it. This is a simple one-file framework that you can implement. So this is the fun and the joy of the decoupled components, is that you can choose whichever one you want to use, and you can build your own stuff with it without any hassle. These components are tested or used by a lot of other frameworks, so you can be sure that